All right. Good afternoon, everyone. Thank you all for joining us today for this SANCOLD YPF webinar. I'm Ashley Kutsia, the YPF chair at SANCOLD, and it's a pleasure to welcome you all to what promises to be an insightful and engaging session. Today, we are honored to have Dr. Mike Shand from Zutari with us. Dr. Shand has had a distinguished career in civil engineering. He obtained his degree from the University of Cape Town, followed by both his master's and PhD degrees from the University of California at Berkeley. In 1969, he joined Ninham Shand, which is now part of Zutari, and for over 20 years, he has played a pivotal role in the planning and development of schemes to augment the Western Cape water supply system. This system is critical not only for the city of Cape Town, but also for surrounding towns and irrigation along the Berg and Riviersonderend rivers. Today, Dr. Shand will be sharing his expertise on Western Cape water supply system, a topic of immense importance given the challenges of water security in the region. Before we get started, I would just like to share a few housekeeping items. Mics will be muted during the presentation to minimize disruptions. If you have any questions, please feel free to type them in the chat during the session, or you can raise your hand during the question and answer session at the end of the presentation. The session is also being recorded and will be made available after the event for those who want to revisit any parts of the presentation. So without further ado, Dr. Shand, thank you again for joining us. The floor is yours.
Okay, can you hear me?
Yes, I can hear you.
Okay. Just trying to find my presentation. Have you got it?
I can't see it yet.
Okay, maybe you must talk me through again.
Okay, so next to your mic where you unmuted, there will be the share button on Microsoft Teams.
Okay.
And then you go to Window.
Sorry. SANCOLD chat. Okay. All right. Teams, yeah. Okay. Okay,
So,
I'm on Teams. Yeah.
okay, then just go to the share button at the top of the screen.
Yeah, I've clicked it.
And then you go to Window.
Where do I find that?
After you've clicked share, there should be either screen or window option.
I've got raise hand, chat, whatever.
Okay, then you need to go to share.
Share screen. Okay.
Yes. Then you go to Window.
There we go. All
right. And you can just start your presentation.
Okay. Is that full screen for you?
Not yet. And you just go to the bottom.
Oh, goodness, I've lost it again.
Sorry. Can just go back to PowerPoint. No, you are sharing, don't worry. Let's go back to PowerPoint.
Okay. Okay.
Okay, and then just click on your PowerPoint presentation, and then you can just go to slideshow.
Trying to find slideshow.
Yes, you were almost on it. Slideshow is like in the middle of your bar there.
There we go. There we go.
Yes.
Okay.
And then from beginning, which is the first option on the left-hand side.
Sorry, I'm just trying to find. How do I haven't got slideshow. Stop sharing. I'm shared. Just start the slideshow. Sorry.
Okay. I can't. I
You
can't
can't
do
see.
it, so yeah. So you
Yeah,
just
in
need to go to
slideshow, there we
slideshow,
go,
which is in the beginning, in the middle,
which I've
yes.
done. And then,
Yes. You need to click on it and then let it open up. Maybe it will be easier just to click on that button next to the minus at the bottom of your screen on the right-hand corner.
there we go.
Yes, just click on that
There we
button.
go.
Okay, good. There we go. We can start.
Okay, sorry everybody about the the hiccups.
No
But
problem.
age matters in these things. So the title of my talk today is the Western Cape Water Supply System. I got involved with this system more than 20 years ago. Peter van Niekerk of the Department of Water Affairs came to see us. I was with the predecessor to Zutari at that stage, and then Shand, and said that they were looking for a firm, or they were inviting our firm. That was the days before you had to tender for your work, inviting our firm to work with BKS on setting up a system model for the Western Cape water supply system. And that led to the development of the model, and I've had fairly close involvement with the system since then. And a number of the schemes that I talk about today were identified at that time, including the Berg River Dam, which at the time was known as the Skaefram Dam. So I'll go on to start the slideshow. The Western Cape water supply system supplies a number of users. The urban users are the city of Cape Town, which has a population of nearly 5 million today, which is increasing quite rapidly at about nearly 2% per annum. And also the towns of Paarl, Wellington, and Stellenbosch, and some minor towns. It also serves the irrigators along the Berg River and the Riviersonderend rivers and the Eerste River. This figure is from the city's proposals for new schemes, and it shows the historical water demand. You can see that fall in the water demand represented by the black line was during the drought, and it is expected that the demand will recover and follow probably that black line that is marked with my cursor. So there are quite considerable demand increases that are anticipated in the future, and the yield of the existing scheme is insufficient to meet that demand. About 1/3 of the demand is for additional demand to this is for irrigators. The system itself comprises a number of dams, which are shown here. They are mostly located in the mountain range, the Hottentots, Holland, and the north, then to the north, the mountain range. And our water is then brought to Cape Town by a number of pipelines, which I'll discuss to some extent. The main dams are shown here. The original dams were the Table Mountain dams, and I'll speak about each of these later. That was followed by the Steenbras Lower Dam, and then the Wemmershoek Dam, and thereafter Voelvlei Dam, the Steenbras Upper Dam, Theewaterskloof Dam, and that's it, I guess. So the city of Cape Town's dams are the 5 small dams on Table Mountain, and there are 2 small dams on Simonstown Mountain, which were built or constructed at the time that Simonstown was an independent municipality, and its water was supplied to the town by its own dams. Then the city's first dam was the Steenbras Lower Dam, which has been raised a couple of times, and the Steenbos Upper Dam, which forms part of the city's Steenbos pump storage scheme, 180 megawatt pump storage scheme. The Department of Water Affairs dams are, the first dam was Volvlei Dam, which also supplies irrigators. Then that was followed by Theewaterskloof Dam and the Riviersonde and Berg River, Easter River Tunnel System, which brings water from Theewaterskloof effectively to Cape Town, to the vicinity of Fora. And then the next scheme was the Koelgeberg and Rockview dams, which are part of Eskom's 400 megawatt pump storage scheme, Palmet pump storage scheme, which also transfers water during off-peak periods into the from Koelgeberg Dam into Rockview Dam, from where it is released into the Upper Steenbos Dam. And then we have the Berg River Dam, and the supplement scheme was the most recent scheme that was commissioned. So these are approximate dates. The small dams were built in about 1900, Simonstown Dam in 56, Steenbos Dam in 2021, which was raised in 56, Vermershoek Dam in 57. And then the department built Volvlei Dam originally in 52, and it was raised in 69. Theewaterskloof and Kleinplaas dams in 1983. I think Kleinplaas was slightly later. And the Berg River Dam and subsequent supplement scheme in 2009. These are two of the dams on Table Mountain. It's worth a visit if you haven't visited them. They're easily accessible. If you can walk from Constantia Neck up the road that goes to the top of the mountain. These are, because they're interesting stone masonry dams, very spectacular. Both the Healy Hutchison and Woodhead dams were actually strengthened a number of years ago with pre-stressed cables because they were found to be unsafe in terms of the modern dam safety guidelines. Then this is a close-up view of the Steenbos Dam. The original Steenbos Dam is here on the left. The Upper Steenbos Dam is on the right. And the Steenbos pump storage scheme is in this vicinity. And the lower dam, you can't quite see, it's not in the picture. But water can be transferred to Cape Town from the Steenbos Dam. And also now there's a pipeline from the Upper Steenbos, from the Lower Steenbos Dam of the pump storage scheme to Fora. Then the Palmet pump storage scheme comprises the Koelgeberg Dam and Rockview dams and the pump storage scheme here. And water is released from the upper dam into the Upper Steenbos Dam. This is a photograph of the Steenbos concrete cavity dam, which was raised in 1956 with pre-stressed cables. The Steenbos Upper Dam is situated in the headwaters of the Lower Steenbos Dam. And as I said earlier, it supplies water to the pumps. It also serves the pump storage scheme and supplies water to Cape Town via releases or from the Lower Steenbos Dam directly to Fora. The water from the pump storage scheme is delivered down a channel into the Upper Steenbos Dam. This is the Koelgeberg Dam, which was built by the Department of Water Affairs on the Palmet River. It's a concrete gravity dam with a typical Robert splitters, which is a design which was developed by the Department of Water Affairs and is included in a number of their dams. It comprises steps or splitters and a shelf, and distributes the flow over the spillway over a wide area. If I can just orient you, this is Theowaterskloof Dam here, which is quite a very big reservoir, and it releases water to the Riviersonde end. And water is then taken back via the tunnel system all the way through to Kleinplaas Dam here. And en route, there are a couple of shafts which divert water into the tunnel system. The Berg River Dam is situated here, and the Berg River Supplement Scheme here. I'll talk about these now. The supplement scheme delivers water during high flow events into the Berg River Dam, and water from the Berg River Dam can then be pumped back into the tunnel system. Water from the Berg River Dam is also released during the summer for the ecological flow requirements and to supply irrigators. This is the Wemmershoek Dam, which has a gated spillway. It's city, the dam belongs to the city. And there's a water treatment works, and the water is then delivered via the Wemmershoek pipeline to Cape Town. That's a view of Theowaterskloof Dam, not of the dam wall itself. It's a large dam, large lake, as I said. And that dam, Theowaterskloof Dam, delivers water via the tunnel system, Kleinplaas Dam, through to Fora, here, the Fora water treatment works. And water, as I said earlier, is pumped from the Berg River Dam, can be pumped, into the tunnel system. This is a view of the Berg River Dam. It's a concrete-faced rock-fill dam. And that wall there is actually a wave wall. It's quite necessary because the prevailing wind is from the left. It's a sort of prevailing southeast wind during the summer. And quite considerable waves occur and run up, particularly because it's a concrete face rather than a rock-fill dam. Another view of the Berg River Dam, and I'll speak quite a lot about this because the spillway was model tested. So particularly the spillway in the foreground, which comprises a sort of modified side channel spillway, and then a chute at the bottom. That's a view of the spillway chute under construction and the overflow section at the top of the chute and the ski jump at the bottom. On the left are two sleeve valves which can release low flows into the river. And I think there are two small ones as well. There's also a second spillway, a second release mechanism via a tunnel, and ski jump that was put in to release an annual flood. At the time that this dam was constructed, Minister Kader Osmal was Minister of Water Affairs, and he was very influenced by an environmental consultant who insisted that the ecological flows in the Berg River should be met, and those comprise not only the low flows, but also a flood at least once a year equal to the annual flood of 160 cubics. 160 cubics is a very large flow. This shows the spillway, which was model tested by the Department of Water Affairs, and that's where these splitters were developed. It's a relatively narrow channel, and I'll show you pictures of the model testing by the department. That shows a very small overflow and the ski jump actually in operation. One must always bear in mind when you design a ski jump that there are low flows that will trickle over the spillway, trickle over the ski jump because they will not jump clear. And one must guard against possible erosion immediately downstream. This is the model that was tested by the Department of Water Affairs in their laboratory in Pretoria. Just a small flood over the spillway. Just note that because of the energy of the flow coming in, this spillway has sort of splitters on it. There is quite a high boil on the left-hand side. In other words, the energy is only partially it's not a drowned hydraulic jump, or it's only a partially drowned hydraulic jump. Then the water flows at right angles to what we're looking down the channel. That's a view of the high flow of the major flood in the spillway. I think this was the RMF or the PMF for which it was designed. There's a view of the ski jump in operation in the spillway model. This is actually the bottom release, the 160 cubic bottom release that was operating. And if you see where my cursor is, because of the high energy that contained in this water where it impacts, there's an increase in water level of something like 2 to 3 meters at this point. So you get a very substantial reverse flow from left to right back to the dam. And one must bear that in mind, particularly if the toe of the dam is an embankment dam. This is a photograph of the gate which is making that release. I understand they've had some problems with the seals at that gate. And then the sleeve valve that you can also see discharging. This is a view of the supplement scheme. This was model tested by then Prof. Gerrit Besson at the University of Stellenbosch. It comprises a broad-crested weir, a fishway, and a canoe chute, and then a desilting works. This berm was removed that you see here was removed after construction, and there are 2 flushing gates here to flush this channel should sediment be deposited in there. And then when the water is taken out, there's some culverts under here into the sediment traps, and from there the water without sediment is transferred into a storage dam from where it is pumped back into the Berg River Dam. Then we turn to the Berg River Dam was the last scheme constructed, but we go to this is the furthest scheme, the Voorvlei Dam, also owned by the Department of Water Affairs. It's served by an 80-kilometer pipeline. It's an off-channel dam. It's fed by the 24 Rivers Canal. There's a small dam on the 24 rivers, and then this long canal which intercepts water from the Leeu River and other minor tributaries and delivers it into the dam, and also intercepts water from the Kleinberg River via this Kleinberg River diversion. The proposed Brevis future scheme will pump water from the Berg River into the Voorvlei Dam. And there's another proposed scheme possibly to divert water from the upper reaches of the Breda River, the 24 rivers, into Voorvlei Dam. This was a photo of the outlet works, the irrigation intake for the outlet works for the irrigation releases. This was taken during the drought when the dam was severely drawn down, and Cape Town had very severe water restrictions. The photo of the pump station for the 80-kilometer pipeline to Cape Town via the water treatment. And this is the existing 3-meter diameter, 80-kilometer pipeline to Cape Town. And it is planned to provide an additional pipeline. This is a pre-stressed concrete pipeline. The next scheme is probably going to be the Berg, or is planned to be the Berg River Full Flow Augmentation Scheme, known as BRAVAS, BRVAS. This scheme will yield 23 million cubic meters per annum and will comprise a weir on the Berg River pump station and then the pipeline to Full Flow Dam. There will also be desalting works and possible additional future augmentation schemes. Obviously, water conservation and demand management is a focus, including pressure management. This is the most cost-effective way of reducing water demands and obviously prolonging the life of the schemes. Then there's surface water schemes, groundwater schemes, and water reuse. Something I didn't mention is actually alien clearing, which is very important in terms of alien vegetation consumes much more water than fynbos. And so there's a major program to actually remove alien vegetation plants, particularly black wattles and other similar plants, which consume a lot more water than fynbos. Then possible future surface water schemes are the Breedeberg River transfer scheme, the raising of Lower Steenbos Dam, a possible Lower Palmeet diversion scheme, which would be a pumping scheme. There are two possible phases for that scheme, which one would include a dam, the other would be just a pumping scheme. The so-called Berg River Full Flow Augmentation Scheme, phases 2 and 3, which would take more water from the Breede River, but the concern is that it will affect water which is abstracted at Brandvlei by the pump station at Brandvlei, because it will affect flows in the Breede River. Then the raising of Full Flow Dam, the possible phases, and then other diversions, the Elands River, the Upper Molenaars, the Upper Wit River, both a dam and a diversion, and perhaps increasing the yield of Full Flow Wimmershoek Dam by a pumping scheme. There are future groundwater schemes as well, the Table Mountain Group Aquifer in Neverberg area and the Kroonberg area, the Cape Flats Aquifer that's on the Cape Flats in the vicinity of Hanover Park, Strontfontein and Philippi, and Mitchell's Plain. And then the existing aquifer at Atlantis, which were further phases of that scheme, and the Longabon Road aquifer. Thank you.
Right, thank you so much, Dr. Shand. I really appreciate that insightful presentation. I enjoyed seeing the model studies in line with how Cape Town gets at water. I will now open up the floor for any questions or comments that you might have. You're also welcome to type them in the chat.
Hello?
I'm just waiting for some questions. Okay, cool. I've got one hand up now. I've allowed your mic so you can unmute yourself and just ask your question.
Good afternoon, Dr. Shand. Thank you for such a wonderful presentation. I just wanted to check, in terms of water augmentation, how far can agriculture contribute towards releasing some additional water in terms of, improving their efficiency, since they are one of the biggest users of water?
Yeah, the agriculture, actually in the Western Cape, agriculture is very efficient in its water use because they have a limited supply So they make actually very efficient use using almost either drip, very frequently using drip, which is probably the most shall we say, water efficient mechanism of using. So whereas sprinklers, you do get higher evaporation. So it's very heavily focused on water conservation and maximizing the benefits that you can get from the available water, because they know that there is no more water available to them. Their supply is limited. Have I answered your question?
Yes, I think perfectly. Because I thought maybe they're using sprinkler, there might have been room to improve and move to drip, or gain efficiencies from drip. But if they are already in that spectrum, then there probably won't be any wins from that side.
Yeah, I think it's in here. This area, it is particularly because of the limited, because they know there's no more resource available to them. So they're making absolute maximum use to maximize their crops, and much of what agriculture uses in the Western Cape is actually export fruit and mainly fruit. So it's valuable foreign exchange to our country.
All right, thank you very much for that question and answer. We have a question in the chat from Rasi Nivot. He's saying, Dr. Shand, what will be the impact of the TMG groundwater development on surface water runoff?
The TMG aquifer is actually it will have a minor effect. And in fact, the city of Cape Town has in fact installed gauging stations in the Steenbos area to monitor flows prior to and post abstraction, because they have drilled a number of abstraction wells in the vicinity of Steenbos Dam. So the purpose is, it's not certain at this stage. It's quite a deep aquifer, but nevertheless, the aquifer does daylight effectively in the high mountain areas, and there may be an effect on that. So yes, it's a good comment, and it's unknown, but it is to be studied. And as I say, gauging stations have been put in place to enable that consequence to be monitored.
Right, thank you so much. If you have a follow-up question, you're welcome to ask. So we have another question from Dr. Gert Kloete. He is asking, raising Voelvlei Dam implies it cannot be gravity fed from its main source, the canal from Nuwe Kloof. So pump stations will be required. Pump storage? Question mark. I'm not entirely sure what the question is, but
No, there's no possibility of pump storage, but not there. There was a pump storage scheme that was planned in that area, but I don't think it's one that will be built. I'm not party to what Eskom is considering. But raising a Voelvlei Dam, yes, it would affect. One would have to pump water from the Kleinberg River. I think from the 24 rivers, it may be able to gravitate, but I'm not sure. But you make a good point, and I think people are fully aware of the implications.
right, thank
It's
you,
unlikely now that the Voelvlei Dam will be raised. I think the proposed scheme doesn't include raising. It includes it's mainly additional pumping capacity to maximize the yield of the dam, because it's already quite a large dam. In other words, additional pumping capacity and additional pipeline capacity to Cape Town.
Okay, thank you for that answer. I have one more question in the chat, and then I will go over to Prof. Van Vuuren with his raised hand. So Aldre Nell is asking, Dr. Shand, thanks for a very insightful presentation. Do you know whether any alternative spillway designs were considered and scaled lab models tested for Berg River Dam?
No, no alternative was considered. The problem with the Berg River Dam is the site is not very favorable for, well, first of all, it was decided that it's a very wide valley, and it should be a rockfill dam was the most appropriate dam for the type of site. It would have been a very long wall concrete dam. So you then are limited to the kind of spillway. So it was possible that and then you are limited because it's an embankment dam to some spillway on the flanks, and the side channel was the most appropriate of that, and it's actually quite an efficient spillway, I think, that has been developed by the department at that dam.
Thank you for that answer. Prof. Van Vuuren, your mic has been enabled. You can unmute yourself and just ask your question.
Good afternoon, everybody. Ashley, thank you for organizing this and handling the discussion. It was nice to hear Dr. Shand's presentation. Good day, Mike. And the question I have is, we had some experience of desalination plants that were constructed during the extremely drought period prior to the excessive flow that you have at the moment. Desalination remains I think, a fairly expensive alternative. But is there any plans in the future to consider that? And obviously, one of the limiting factors in South Africa is the power supply, which goes hand in hand with the development of any of such scheme. Your views on that will be appreciated. And then in a lighter vein, if you've got a lot of water currently, please send some to Namibia where it's extremely dry. Thank you for listening to you, Mike. Thanks.
Well, as long as you build the pipeline and pay for it, that will be fine. We'll send it to you. Look, the aquifers are... Sorry, would you mind repeating your question to just the gist of it? Yeah.
Thank you, Mike. Yes, building the pipeline seems to be a fairly exciting new project for the younger generation. Good luck with that. The question was pertaining the option of desalination, and with the past experience and current new development in technology, that's the one issue. The other one is obviously the new research results from the brine that has to be pumped back to the sea, which apparently do have a big impact. So the question is, how do you see desalination as an option for water supply to that part of the world?
Yeah, no, desalination is the ultimate. It's actually not actually in Cape Town's plan at the moment, but it is obviously, and so they're concentrating on actually minimize leaks. They have a very intensive pressure management program in place. But you're correct, ultimately we will have desalination. And a site in the vicinity of Koeberg seems to be the most favorable site for a possible desalination plant. And then it would probably pump water from there to Tygerberg reservoirs and introduced into the reticulation in that vicinity. But it is expensive. we've suggested that they should site it at the outlet of Coburg, because you have warm water, and warm water is easier to desalinate than the icy cold water on the west coast. But they don't seem to favour that. But it's likely to be in the vicinity of the Coburg intake, the intake system for a desalination plant, and that will be the ultimate for Cape Town, because there is no other source once you've maximised reuse. Have I answered your question?
Thank you, Mike, for the explanation. And it's an expensive one, but hopefully we can improve on the technology. Thank you very much.
All right, thank you. Thank you for that. We have one follow-up question on a previous one, or comment. So this is again from Rashi Nuvert with regard to the TMG groundwater development on water's surface runoff. So the TMG target yields are significant. In Limpopo province, the river flow characteristics change dramatically with increased groundwater abstraction and use. Those deep aquifers need to be augmented. This needs to be monitored very carefully. The impacts of deep aquifer development may not always be in the immediate region of the groundwater development, but some distance away. So it's not just a comment. So I don't know if you want to add something to that.
No, except that is exactly why the city is, I think they've been fairly careful in selecting the small tributaries which supply Steenbos Dam, so that they are in the vicinity of where the anticipated effect of withdrawal from the TMG aquifer will occur. I might say concern has occurred is that the water quality of water in the TMG aquifer is not compatible with water in Steenbos Dam, so that it seems that you have to deal with it separately. You can't just put it into the dam and abstract it.
All right, thank you. We have another question from Ellis Michael saying, have not had any feedback on the Berg River radial gate, but believe the seal problem was addressed in 2015. No news is good news, ?
Yeah, I'm not sure that they've made any release subsequently to replacing the seal, but I was aware that they had a problem with the seal. But maybe somebody from the department can comment. I don't think there's no subsequent release has been made, and those requirements of Prof. Carter Asmal that you should release a flood, though no flood has been released subsequent to that trial release, basically, and I'm not sure what monitoring of the ecological flows in the Berg River is taking place, but I'm not sure, and maybe there's an ecologist who can comment. But I haven't heard any feedback, or hadn't had any feedback to say that the environmental of the Berg River has deteriorated significantly.
All right, thank you. I'm going to take one last question. Unless there's any pressing ones, please raise your hand now. Andreas Brooks, you can unmute yourself and ask your question.
Hi, good afternoon. Thank you, Dr. Shand, for the insightful presentation. In light of Prof. van Vieren's comment, I think I would just like to add a comment on desalination for the city. The city is indeed in the process of developing and investigating desalination as part of the new water program, in addition to groundwater and the reuse schemes that are planned. And the first plant will have an estimated capacity between 50 to 70 megaliters per day. Thank you.
Could you mention where it would be located?
The area more or less will be in Pond Island.
Okay, thank you.
All right, thank you so much. I really appreciate everyone's participation in this insightful session. And once again, thank you so much to Dr. Shand for your time.